All right, so the last video in this series on linear systems is about the properties of linear systems. So what we're going to look at is just see what can happen when we graph a couple of lines. What are the different results that we can have? So the first thing I'm going to do is swap the lines into the y equals mx plus b form, and then graph, and then I'm going to see what happened. So the first one, I'm just going to swap the y and the 1, add y, add 1, add y, add 1. So these cancel, and I get y is negative 2x plus 1. Okay, over here I'm going to move over 4x. 6y is negative 4x minus 18. Divide everything by 6, and I get y is negative 2/3 x minus 3. So negative 2/3 x minus 3 is going to look something like this. So on. So there's my first line. And then the second one, negative 2x plus 1. I'm going to go this. Something like that. And so I can see that here, the line All right, in our second example, I'm going to do the same thing. I'm going to isolate this y, so I'm going to take away x. So y is negative x minus 2. So minus 2, and it has a negative slope, so my line looks something like this. And then I'm going to rearrange this one, so I'm going to add 2x, negative 2y is 2x plus 4, and I'm going to divide everything by negative 2. And I get y is negative x minus 2. And that is the same line right here. So when the two lines are the same, we say that there are infinite solutions, because every point on the line is in common, versus here in the first one there was only one point that was in common. So we can have infinite solutions when the lines are the same, and I have to get them into y equals mx plus b to see that they're the same, because I would look at these and maybe not immediately see that. Okay, and our last scenario here, I have to subtract 3x. So I get y is negative 3x minus 2. So minus 2, and the slope is negative 3. And I get something like this. Okay, so there's my first line. And now the second one, I'm going to add 6x and add 6x. So negative 2y is 6x plus 12. Divide everything by negative 2. Negative 3x minus 6. So that's going to go here. And look something like this. So what happened in the last scenario? I have parallel lines. Parallel lines that are not identical. And there is no solution. These lines will never cross. They will never meet. Okay, so let's put all of that information into a table. So the first scenario that we saw, we had two lines, something like this. They crossed, there was one solution. The slopes were different. and we had one solution. The intercepts of the lines, in this case, they were different. However, they could also be the same. So if you imagine what would happen if the lines had different slopes but the same intercept. Well, say one could look like this and one could look like that. And what that would mean is that the intercept right here would be the solution. Okay, but they would cross. So the moment that I see the slopes are different, I know immediately there will be one solution. In other words, the lines will cross. And then the second one that we saw had two lines that overlapped. So the slopes were the same. The intercepts were also the same. And we had infinite solutions. And then down here in the third case, we had two lines that were the same slope, but they had different intercepts. So that's the thing. Once they see that they have the same slope, that doesn't help me to differentiate between infinite solution and zero solutions. The next thing I need to look at is here, the intercepts. Are they the same? Is it the identical line? Or do I have parallel lines that will never meet and give me no solutions? So now down here, I have a couple of problems for you to try. Change them all into y equals mx plus b format, and then look at them and look back at your chart and see what is the situation you find yourself in, how many solutions are there. Okay. So hopefully you change those all into y equals mx plus b, and sort of just by inspection decided what would happen here. So I'm going to do that just really quickly and say 5y is negative 2x minus 33. So y is negative 2/5 x minus 33 over 5. And that's this one. And then the other one, 5x plus 10 is 2y. So 5 over 2x plus 5 is y. And notice slopes are different. And the moment I see that, I don't care about anything else. So there will be one solution. And maybe some of the clever students also notice that these lines are perpendicular. Negative 2/5 and 5 over 2 are negative reciprocals. So when they cross, they'll make a 90-degree angle. All right, in the second situation, I'm going to have 5x plus 14 is 2y. Divide everything by 2. And that's my first equation. And now the next one, divide everything by 16. And I get y, 40 over 16. That's also 5 over 2. And 112 divided by 16 is 7. So remember, here we have to simplify fractions to make sure that they're the same. So slope is the same, intercept is the same. Here we'll have infinite solutions. All right, and down here, I'm going to rearrange this one. 12y is 14x plus 94 when I switch it to the other side. So divide everything by 12. And I'm going to get 7 over 6x plus 47 over 6. If I reduce that, that's an ugly equation. Okay, and the other one, 7x minus 38 equals 6y. Divide everything by 6. 7 over 6x minus 38 over 6 is y. And that's going to be 7/6x minus 19/3 equals y. So if I compare my two equations, they have the same slope, but they have different intercepts. So I hope you got that there.